Exam 2 review. This is a long review, however, it's designed to give you extra practice and cover everything that might possibly be on the test. Your test will only be about 25 to 30 questions long, so don't worry about that. And remember, we want you to create your formula sheet as we go. So I will be saying things. If you don't know the answer to questions that I ask, those may be things that you need to add to your formula sheet. So you might want to keep out a separate sheet of paper just to look at that or add to that as we go. Exam 2 review number 1. For which of the following scatter plots is the correlation coefficient an appropriate summary? What shape do we have to have in order for the correlation coefficient to be relevant? Or there needs to be a linear relationship in order for you to use the correlation coefficient. So your scatter plot needs to be linear. This is not linear, it's kind of curve shaped. This one has no relationship whatsoever. B looks to be somewhat linear, and then our other choice here is C, which once again does not look linear. So the correct answer here would be B. In order to use the correlation coefficient in an appropriate summary, your scatter plot has to show some sort of linear correlation. This would be an example of positive linear correlation. Positive because it's going up. Number 2 is characteristics of the relationship shown in the figure. Looking at this scatter plot, would you say that this is a negative nonlinear relationship, negative linear relationship, positive linear relationship, or positive nonlinear relationship? Look at the shape of these dots here. It's positive nonlinear, positive because as you move from left to right it's going up and it's not in a straight line, so it's nonlinear. Number 3 says to compute the correlation coefficient. In order to compute the correlation coefficient, we're going to have to go to our calculators. What's the first thing I need to do? Put the data into the calculator. So we're going to hit Stat, Enter to go to our list. I'm going to put the X's in list 1 and the Y's in list 2. Once you have your data into a list, what do you need to do? Your second mode takes you back to the home screen. And now what? So we hit the Stat button, Calc. We wanted to use the linear regression equation on number 8, so we're going to hit 8. Our X's are in list 1, our Y's are in list 2, and we go down to Calculate, hit Enter. And I don't see my correlation coefficient, so what do I need to do on my calculator that you probably don't have to do on yours? Turn on the diagnostics. And how do I turn on the diagnostics? Second 0 takes me to the catalog. Turn your diagnostics on, select diagnostics on, hit enter, and then we can do the same thing again. We hit Stat, Calc, number 8, and calculate. And there's my correlation coefficient. Which one is it, the R or the R squared? The R is your correlation coefficient. So this would be 0.899 if we rounded it to 3 decimal places. We did this by hitting Stat, Calc, 8. Number 4 says one of the primary feeds for beef cattle is corn. The following table presents the average price in dollars for a bushel of corn and a pound of ribeye steak for 10 consecutive months. Compute the correlation coefficient between the corn price and the ribeye price. What's the first thing I need to do? Put my data into a list. So we hit Stat, Enter. If you have data in your calculator to clear them out, move your cursor up to the name of the list, hit Clear, and then Enter. Once you get your data into the calculator, what do? Second mode. And then Stat, Calc, 8. Our data is already in the correct list, so we go down to Calculate. We hit Enter. And what is our correlation coefficient to 3 decimal places? 0.815. That would be our correlation coefficient. Number 5 says the following table presents the number of police officers per 100,000 citizens and the annual murder rate per 100,000 citizens for a sample of cities. So in the first column we have the police officers, and then in the second column we have the murders. The correlation coefficient between the per capita number of police officers and the per capita murder rates is negative 0.666. Which of the following is the best interpretation of the correlation coefficient? First of all, that correlation coefficient is negative. What does that indicate? It means that it's going down. With a negative correlation coefficient, it means you have a decreasing linear relationship. So how would we express that? Higher murder rates make it more difficult for cities to hire police officers. Does that have anything to do with the correlation coefficient? No. The per capita murder rate tends to go down as the per capita number of police officers goes up. Yeah, that one sounds reasonable. That one's it, actually. Because whenever you're looking at your graph here, let's kind of flesh this in a little. If I were plotting this data, my number of police officers would be along the horizontal axis. The number of murders goes on the vertical axis. So as the number of police officers gets larger, the murder rate is going down. Does that make sense visually now looking at the graph? This would be B. Number 6 says to compute the least squares regression line for the given data set. So we go to our calculator. We first have to put the data into the calculator, which means I need to clear this data out. Once you have your data in your calculator, you do what? Go home, second mode. Now I want to find the least squares regression line. It's the same process that we used to find the correlation coefficient. I just look at the rest of the answer. So I hit stat, calc, 8, calculate. So for this output from my calculator, what would be the equation for the least squares regression line? Y equals, how do I write my answer? This is telling you the pattern. Your constant term is going to be the number that you get for A. Your variable term is going to be what x is multiplied by. That's the number that you get for B. So I would write y equals 12.359 plus 2.294x. Y equals your constant term plus your slope times x. I believe the answer key reversed the orders and they put it in y equals mx plus b form, but because we're using this for the calculator, I'm fine with this for an answer. Know that this is mathematically equivalent to this. Both of these answers are acceptable. Notice they're the same answer, I just switched which term went first. They're mathematically equivalent. If you have this question on a test, the answer would be multiple choice. What's important is that the number that's by itself is the 12.359. The number that x is multiplied is what's in the position of B here. That's the 2.2942. Number 7. One of the primary feeds for beef cattle is corn. The following table presents the average price in dollars per bushel of corn and a pound of ribeye steaks for 10 consecutive months. The least squares regression line for predicting the ribeye price from the corn price is given by this equation right here. If the price of corn differs by 35 cents per bushel, by how much would you expect the price of ribeye to differ? How do I use this least squares regression line in order to come up with the answer? X represents the price of corn, and this is the slope of the line. So for each 1 unit increase in X, I'm going to have a 2.3437 increase in Y. That's how you read the slope of this line. So if the price of corn differs by 35 cents per bushel, it's going to change, or the answer is going to change by 0.35 times the slope of the line here, 2.3437. It's just 0.35 times 2.3437. And rounding your answer to the nearest penny, you get 82 cents. What this means is that if the price of corn differed by 35 cents per bushel, we would expect the price of the ribeye to differ by 82 cents. No, this is the y-intercept. That just tells you where the graph would cross the y-axis if the corn were free. On these types of problems, you use the slope of the line. The slope is what x is being multiplied by. You would multiply this difference by the slope. I don't believe we ever did anything with the y-intercept that was useful. Number 8, one of the primary feeds for beef cattle once again is corn, and we've got this information. Now we're told that the least squares regression line for predicting the ribeye price from the corn price is given by this function. Predict the ribeye price in a month when the corn price was $6.40 per bushel. Now I'm using this to predict. They're giving me a price for the corn, and we were told that corn was X. That price gets plugged into this equation in place of x, and y, we are told, is the price of the ribeye. So when I plug this in to my line, I end up with y, which is the price of the ribeye, equals negative 4.8904 plus 2.8678 times that 640. And I put this in my calculator. and I see that the price of ribeye should be $13.46 a pound if corn is selling for $6.40 per bushel. Whenever you're predicting, you plug in the value that you're given for x into this regression equation and you solve for y. Predicting means take your answer that they give you for x, plug it into the function, and solve for y. That's how you use that line to predict. Number 9. The common cricket can be used as a crude thermometer. The colder the temperature, the slower the rate of chirping. The table below shows the average chirp rate of a cricket at various temperatures. Compute the least squares regression line for predicting the temperature from a chirp rate. How do I do this? First thing I got to do is put your data in the calculator. So we hit Stat, Enter, clear out the data that's already there. Clear, Enter, clear, Enter. Once you have your data in your calculator, what do? Not stat calc. We got to do second mode first, then stat calc. I'm glad you said that. So from the home screen, we hit stat, go over to calc, number 8, calculate, and here's our output. We were told to compute the least squares regression line for predicting the temperature. How would I express that least squares regression line? It has to be a line, so it's y equals what? 21.6. A is the number that's by itself, not multiplied by anything. And then B is what x is being multiplied by. So there's your least squares regression line. Number 10. The following display from a graphing calculator presents the least squares regression line for predicting the price of a certain commodity, y, from the price of a barrel of oil, x. So the price of the commodity is y, the price of a barrel of oil is x. Write the equation of the least squares regression line. Looking at this output, it's very similar to what we just had from our calculator. How would I express this line? Y equals 3.72 plus 0.49x. Number 11. The following display from a graphing calculator presents the least squares regression line for predicting the price of a commodity from the price of a barrel of oil. What is the correlation between the oil price and the commodity price? Which one of these numbers represents our correlation coefficient? R is our correlation coefficient. This would be our answer right here. What do we call R square here? That's our coefficient of determination, which we're going to be asked to find in number 12. So let's look at number 12. For the following data set, compute the coefficient of determination. That's just the R squared. So we go to our calculator, put our data into the calculator, but first clear out what you have in there. Go to your home screen by hitting second mode. Then we hit stat, go over to calc, number 8, calculate. And what is our coefficient of determination? The answer here would be R squared. Correlation coefficient, coefficient of determination. You need to keep those straight or put that on your formula sheet. R is the correlation coefficient. R squared is the coefficient of determination. Number 13. A mini-tab style residual plots are shown below. Which one of these plots indicates that it was appropriate to compute a least squares regression line? These are the residual plots, not the scatter plots. In order to calculate the least squares regression line, your residual plots need to have no discernible pattern. So on B we see a pattern, on C we see a pattern, on D we see a pattern, which is why A would be the correct answer. If you're looking at residual plots, you don't want to see a pattern if you're going to use a least squares regression line. If you're looking at a scatter plot, you want to see a linear relationship. The first problem that we had on the review was the scatter plot. So on the scatter plot, you want to see a linear relationship, but on the residual plot, you don't want to see any relationship between points. Number 14. For the following data set, how much of the variation in the outcome variable is explained by the least squares regression line? In order to do this, we need to find what on our calculator? R squared. First thing we do is we put our data into the calculator. So clear out any data you have in your list. And then go to the home screen and then hit Stat, Calc, 8. What is the percent of variation that's explained by the least squares regression line? Give it to me as a percent. Round it to 1 decimal place. We look at the R squared here, and that number indicates that this would be 9.7%. Remember, to change the decimal to a percent, we have to move that decimal 2 places to the right. On a multiple choice test, I would have answers for both r and r squared as the choices. It's important that you know what each of them are for. R is the correlation coefficient. R squared is our coefficient of determination. It gives us the percentage of variation in the outcome variable that's explained by the least squares regression line. Now we're going to move away from correlation and regression and start looking at probabilities. In number 15, we're told that a 12-sided die can be made from a geometric solid called a dodecahedron. Assume that a fair dodecahedron is rolled. The sample space consists of all 12 numbers representing the 12 sides of the dice. We're asked to find P of 8. P of 8 just simply means the probability that the die lands on 8. If you'll recall how I told you to calculate probabilities, the probability of an event is equal to the number of elements in the event divided by the number of elements in the sample space. This is our sample space. So the number of elements in our sample space for this problem is 12. How many elements are in my event? If my event is rolling an 8, how many ways can I roll an 8? Just one way out of 12 elements in my sample space. My answer here would be 1/12. Number 16, a 12-sided die can be made. Okay, we've got the same 12-sided die. I'm not going to read that again. Now we're asked to find the probability that we roll a number less than 5. Our event is we roll a number less than 5. What are the elements in the event? 1, 2, 3, 4. These are the 4 numbers on the die that are less than 5. So to get the probability, I take the number of elements in my event divided by the number of elements in the sample space, and then I need to reduce that fraction. Number 17. In a poll of 451 university students, 193 said that they were opposed to legalizing marijuana. What is the probability that a surveyed student opposes legalization of marijuana? Whenever you have these probability problems like this, I think it's a good idea if you identify what your event is, what your sample space is, and then how many elements are in your event and how many elements are in your sample space. Because that's how we find the probability of an event. We look at the number of elements in the event divided by the number of elements in the sample space. For this problem, our event in words is what? Opposing legalization of marijuana. Can I identify how many elements are in my event? Am I told that in the problem? 193. What is my sample space? And then the number of elements in my sample space is equal to 451. For this problem, I'm asked to find the probability that a surveyed student opposes legalizing marijuana. Well, that's finding the probability of this event. So I take the number of elements in my event divided by the number of elements in my sample space, and I need to go to my calculator to get a decimal approximation for this number. We'll call that 0.428 if we're rounding to 3 decimal places. Everything always comes back to this that I have written in green. That's how we find probabilities. It's the basics. Number 18. For this year's mayoral election, voter dissatisfaction is very high. In a survey of 500 likely voters, 210 said they plan to write in an independent candidate rather than vote for the Democrat or Republican candidate for mayor. The piece that I am missing, I'll handwrite it in. So for this, we want to find the probability that a surveyed voter plans to write in an independent candidate. Once again, we go back to that formula that I had written in green. The probability of this event is going to be equal to the number of voters who said that they were going to write in an independent candidate, which is how many? Divided by the number of elements in the sample space, which is 500. And when you put this in your calculator, what do you get? Number 19. A section of an exam contains 2 multiple choice questions, each with 3 answer choices listed A, B, and C. List all the outcomes of the sample space. So we have 2 questions on the test, and there's 2 answer choices. So I could write A for the first and A for the second. A, B, A, C. And those are the 3 different ways that I can answer the first question A and then the second question. Or I could answer the first question with a B and the second one with a B, 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 C. Or I could answer the first question with a C and then the second one would be A, B, or C. This is my sample space. I will have a problem on the test where I ask you about the sample space. This is a list of all possible answer combinations when you have two multiple choice questions with three choices on a test. Number 20. A karate club consists of 46 persons holding a black belt, 52 persons holding a brown belt, and 95 persons holding a purple belt. What is the probability that a randomly selected club member holds a brown belt or a purple belt? So these are mutually exclusive events, or means add. So the probability of brown plus the probability of purple is going to be equal to, how many brown belts are there? Out of how many people at the club? Add all of these numbers together. The number of elements in your sample space is going to be equal to 46 plus 52 plus 95. So the probability that somebody has a brown belt is 52 out of 193, plus the probability that somebody has a purple belt is 95 out of 193. And when we add these together, that gives us 147 out of 193. And what is that when you put that in your calculator? 0.762. I think the hardest part on this problem is determining how many elements are in your sample space. If you weren't careful, you might have said, oh, well, I've got 46 people at the club. Well, you can't have more people with a brown belt than what you have at the club. Number 21. If the probability of A equals 0.76, the probability of B equals 0.4, and the probability of A and B equals 0.27, find the probability of A or B. You should have a formula on your formula sheet that says the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. This is your addition rule if your elements are not mutually exclusive. In 20, we had mutually exclusive events because it was impossible to hold both a black and a brown and a purple belt. There was no overlap here, so I just added the individual probabilities together. On this one, that's not the case. We're asked to find the probability of A or B, and so I just dropped these numbers that I'm given into this formula. In place of the probability of A, I put 0.76, plus in place of the probability of B, I put 0.4, minus the probability of the intersection A and B, that's 0.27. And when I put that in my calculator, what do I get? Did you get 0.89? Number 22. If the probability of A is 0.33, the probability of B is 0.51, and A and B are mutually exclusive, find the probability of A or B. Mutually exclusive just means that there's no overlap. So this piece down here is going to be equal to 0 if A and B are mutually exclusive. So the probability of A or B is just going to be equal to the probability of A plus the probability of B. And when we put that in our calculators, we get 0.84. Number 23. If the probability of A is 0.79, what's the probability of the complement of A? 1 minus 0.79 is equal to 0.21. Complement means you subtract from 1. If you know the probability of an event, the probability of the complement is 1 minus the probability of the event, and vice versa. Number 24. A survey asked 33,083 homeowners how many pets they owned. The results were as follows, and then we've got the information in the table. What is the probability that a sampled homeowner has more than one pet? How many of these have more than one pet? 2, 3, and 4 or more, so that's going to be these right here. You can either find this probability using the complement or straightforward approach. Which approach do you prefer? Straightforward? Using the straightforward approach, our event is going to be equal to either 2, 3, or 4 or more. To get the number of elements in my event, I need to add together 10,546 plus 5,147 plus 685. And what do you get when you add those together? Has somebody done that? 16,300 what? 78. I also need to know the number of elements in my sample space. How many elements are in my sample space? 33,083. So the probability of my event is going to be the number of elements in my event divided by the number of elements in my sample space. And when I put that in my calculator, I get a decimal approximation of 0.495. So almost half of the homeowners have more than one pet. I don't include the 1 because 1 is not more than 1. I don't include the 0 because 0 is not more than 1. These three numbers here represented more than 1. Number 25. If the probability of A complement is 0.61, what's the probability of A? 1 minus 0.61. That gives us 0.39. Number 26. What is the correct relationship between events A and B? Event A is Laura participated in an out-of-town volleyball game at 11 a.m. last Friday. Event B is Laura met with her academic advisor on campus at 11 a.m. last Friday. Can she be in both places and do both things at the same time? No. Since they can't happen at the same time, we would say that they are mutually exclusive. Mutually exclusive just simply means there's no overlap. There's nothing in common. If they can't happen at the same time, there's no overlap. They're mutually exclusive. Number 27 says, what is the correct relationship between events A and B? Event A is Kathleen made an A on her biology final exam. Event B is Kathleen did not make an A on the biology final exam. They are mutually exclusive, it's true, because you either made it or you didn't make it, but there's more involved here since we're talking about the same grade and the same exam. These are complementary events because it's one or the other. Like rain versus no rain, A versus no A. These are complementary events. You can expect to see problems similar to these on your test with the multiple choice like this. So make sure you understand these concepts well. You won't see the exact same problems on your test though. Number 28. What is the correct relationship between events A and B? Number 28. Carl is a college graduate. Carl is a high school graduate. Is it possible to be both a college graduate and a high school graduate? So are these mutually exclusive? No, they're not mutually exclusive. They're not complementary either. In order to be complementary, you have to be talking about the same thing and have one thing negate the other. So like here, Kathleen made an A on her biology final. We negated that by saying Kathleen did not make an A on the biology final. The A and the biology final are the same for both of these statements. One is a yes, one is a no. So they're complements of each other. Just like rain and no rain are complements of each other. Number 29. For the event described below, which of the following represents the complement of the event? Here's the event that's described below. A sample of 471 software DVDs was selected. Exactly 34 of these were defective. What is the complement of exactly 34 were defective? It's either 34 or not 34. So the complement would be this. The number of defective DVDs was not equal to 34. The complement of is not. Number 30. Once again, I want to find the complement of the event. Here's my statement. A sample of 301 software DVDs are selected. At least 34 of these were defective. At least 34 means it could be 34 or more. The complement of 34 or more is fewer than or less than 34. So here's all the defective DVDs listed from 1 to 301. If I'm talking about at least 34, that means that I include the 34 and that would be my event. Everything else here would be the complement of the event, and the way that I would express this would be fewer than. Number 31. We want to find which statement represents the complement of the event. My event is fewer than 41 of these were defective. What would be the complement of fewer than 41? I would say 41 or more. At least 41. I want to include the 41 there. Number 32. Let E be the event that a corn crop has an infestation of earworms, and let B be the event that a corn crop has an infestation of corn borers. Suppose that the probability of E is 0.18, the probability of B is 0.18, and the probability of E and B is 0.12. Find the probability that a corn crop has either an earworm infestation, a corn borer infestation, or both. This is another way of asking us to find the probability of E or B. That's the probability of E plus the probability of B minus the probability of E and B. This is the same formula we had before for calculating probabilities of compound events. So using this formula, I would say that this is equal to 0.18 plus 0.18 minus 0.12. And that should be equal to 0.20, how many? 24? Number 33, same setup. I'm given different numbers now, and I'm asked to find the probability that a corn crop has no corn borer infestation. In this problem, we were asked to find the probability that a corn crop has no corn borer infestation. Here's the probability that it does. If it doesn't, that's the complement. So we do 1 minus the probability of the event, gives us the probability of the complement. Number 34. Out of 829 items checked out of a public library, 282 were fiction books, 294 were nonfiction books, and 253 were videos. What is the probability that a randomly selected item was not a video? So my event is that it's not a video. How many items did I have that were not videos? 282 plus 294. And what do we get there? 576. So the probability of my event is going to be equal to the number of elements in my event divided by the number of elements in my sample space. How many elements are in the sample space? 829. And when you put this in your calculator, what do you get? 0.695. Number 35. On a recent Saturday, a total of 1,100 people visited a local library. Of these people, 260 were under age 10, 496 were aged 10 to 18, 180 were aged 19 to 30, and the rest were more than 30 years old. One person is sampled at random. What is the probability the person is less than 19 years old? This is our event. How do I determine the number of elements in my event? Well, I look at all of the total count of people that are less than 19 years old. So I have 260 that were under 10, that's less than 19, and I have 496 that were aged 10 to 18, that's still under 19, and then that's where I got to stop. What do I end up with? Is it 756? And how many elements are in your sample space? 1,100, that's how many people visited the library. So to get my probability of my event, I look at the number of elements in my event divided by the number of elements in my sample space, and when I put that in my calculator, what do I get? 0.687. Alright, number 36. In a recent semester at a local university, 520 students enrolled in both General Chemistry and Cal 1. Of these students, 88 received an A in General Chemistry, 76 received an A in Calculus, and 31 received an A in both General Chemistry and Calculus. Find the probability that a randomly chosen student received an A in General Chemistry or Calculus. This is my event. The number of elements in my event will be equal to the number of people that received an A in Chemistry plus the number of people that received an A in Calculus minus the number of people that received an A in both Chemistry and Calculus. Do you remember us talking about this? The probability with the word or here. Or is the key word right here. That means you have to add your events together and divide by the number of elements in the sample space. That formula is the probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. In this problem, chemistry would be my A and calculus would be my B. The number of people in chemistry that received an A was 88 plus 76 minus 31. And when we put that in our calculator, what do we get? 133. How many elements are in my sample space? 520. So the probability of my event is equal to the number of elements in my event divided by the number of elements in my sample space. And that's going to be the 133 divided by 520. And what do I get for that? 0.256. Number 37. On a certain day, a cheese packing facility packages 500 units of mozzarella cheese. Some of these packages had major flaws, some had minor flaws, and some had both major and minor flaws. The following table presents the results. So here's our major flaw, no major flaw, minor flaw, no minor flaw. Find the probability that a randomly chosen cheese package has a major flaw. The number of elements in my event is going to be equal to 24 plus 38. Do you see why I have to add those numbers together? Because both of them fall under the row of major flaw. And what does that equal to? 62? How many elements in our sample space? 500. So the probability of my event is equal to the number of elements in my event divided by the number of elements in the sample space, and what is that going to give us? 0.124. Number 38. A poll was taken of 14,972 working adults aged 40 to 70 to determine their level of education. The participants are classified by sex and by level of education. The results follow. A person is selected at random. Compute the probability that the person is female and has a bachelor's degree. Looking at the table, I need the female and has a bachelor's degree. That's just this number right here. So the probability of that event is going to be the number of elements in that event divided by the number of elements in the sample space. What is my sample space for this problem? The 14,972. And when we put that in our calculator, what do we get? We'll call that 257 if we're rounding to 3 decimal places. Number 39, we're asked to find the probability that a person is male or has a PhD. This is our event. To get the number of elements in your event, you will add up all of the people that satisfy the requirement. They're either male or have a PhD. That's these people right here. Since I already have a total for the male column, this is going to be 7,468 plus 42 plus 105. And what do we get for that? 7,615. How many elements are in my sample space? All of those. So the probability of my event is going to be 7,615 divided by 14,292. And when we put that in our calculator, what do we get? 0.525. Number 40. Let A and B be events with the probability of A is 0.7. The probability of B is 0.5. The probability of B given A is 0.4. Find the probability of A and B. We have a formula for the probability of A and B whenever these events are not mutually exclusive, and that is the probability of A times the probability of B given A. Plugging in the numbers that we were given, then this would be equal to 0.7 times 0.4, and 0.7 times 0.4 is 0.28. I didn't need the probability of B because it wasn't something in the formula. On 41, let A and B be events with these probability of A is 0.8, probability of B is 0.6. Assume that A and B are independent. Now, when A and B are independent, the probability of A and B is just going to be the probability of A times the probability of B. The reason we use this formula is because these two events are independent. We use the one in green up here if they're not independent. So this is going to be 0.8 times 0.6, and 0.8 times 0.6 is 0.48. Number 42, let A, B, and C be independent events with these probabilities. Find the probability of A, B, and C. Because they're independent, this is just going to be the probability of A times the probability of B times the probability of C. So that's going to be 0.6 times 0.3 times 0.2. That's equal to 0.036. 43. A fair coin is tossed 4 times. What is the probability that the sequence of tosses is heads, heads, tails, tails? Are each of the coin tosses independent? Yes, they are. So that probability of that event is just going to be the probability of the coin landing on head times the probability of the coin landing on head times the probability of the coin landing on tail times the probability of the coin landing on tail. What's the probability that the coin lands on heads? 1/2. And the probability that the coin lands on tails is 1/2. So this ends up being 1/2 to the 4th power, which is 1/16. And 1/16 as a decimal is 0.0625. Number 44. A fair die is rolled 2 times. What is the probability that both rolls are 3? Are the rolls of the die independent of each other? Yes. So that would be the probability that I roll a 3 times the probability that I roll a 3. What's the probability that the roll lands on 3? How many sides are there on a die? So that would be 1/6 times 1/6, and 1/6 times 1/6 is 1/36, and when you put that in your calculator, divide it out, you get 0.028. Number 45. Let A and B be events with the probability of A equals 0.2, the probability of B equals 0.5, and the probability of A and B equals 0.08. Are A and B independent? No, because if they were independent, the probability of A and B would be 0.1, because that would be equal to probability of A times probability of B. So this would be a no. If they were independent, the probability of A times the probability of B would be equal to the probability of A and B. Since they're not equal, they're not independent. Because if I multiplied these two numbers together for the probability of A and the probability of B, I don't get 0.08. This is the multiplication rule if our two events are independent. We saw in a previous problem, number 40, this is the multiplication rule if our events are not independent. So this is the rule if they're not independent. This is the rule if they are. Because they asked us, are they independent, all I had to do was check to see if this ended up being the product of these two numbers. Number 46, let A and B be events with the probability of A is 0.9, the probability of B is 0.5, and the probability of A and B is 0.45. Are A and B independent of each other? What is 0.9 times 0.5? 0.45. Yes, they are independent of each other, because 0.9 times 0.5 equals 0.45. So the probability of A times the probability of B is equal to the probability of A and B. Number 47. A fair die is rolled 5 times. What is the probability that it comes up 5 at least once? What did I tell you to use when you see the phrase at least once? Use the complement. This right here means use the complement. So our event in words is that it comes up 5. What is the complement of the event? I can roll any number that I want but a 5. The probability of our event will be equal to 1 minus the probability of the complement of the event. Now, in one roll, the probability of the complement is going to be 5, 6, because there's 5 numbers that are not 5 out of 6 numbers on the die. But I'm doing it for 5 rolls. So I've got 1, 2, 3, 4, 5 rolls that are each going to have a probability of 5, 6. So that's 5, 6 raised to the 5th power. So we go to our calculator, and I am going to put this on the video because some people may still be struggling with how to do exponents on their calculator. So to put this in my calculator, I would do 1 minus open parentheses 5 divided by 6, close parentheses, and then hit this caret here up to the 5th power and then hit enter. And I get 0.598. So the probability that a fair die is rolled 5 times and comes up 5 at least once is 0.598. On 48, we're told an unfair coin has a probability of 0.4 of landing on heads. The coin is tossed 2 times. What is the probability that it lands on heads at least once? Because of the words at least once, I want to look at the complement of the event. My event is it lands on heads at least once. Actually, I could actually list the elements of my event. At least one head could be a head and a tail and a head, or a head and a head. Actually, this sample space is small enough. No, I'm gonna use the complement. That's my event. What is the complement of the event? Not heads would be a tail and a tail. Now, the probability of landing on heads is 0.4. The probability of landing on tails is 0.6. So the probability of the complement, 0.6 times 0.6, because these coin tosses are independent. And what is 0.6 times 0.6? That's 0.36. So the probability of my event is equal to 1 minus the probability of the complement of the event. And that's going to be 1 minus 0.36. And 1 minus 0.36 is 0.64. Number 49. The letters A, B, C, D, E, and F are written on 6 slips of paper, and the slips are placed into a hat. If the slips are drawn randomly without replacement, What is the probability that A is drawn first and B is drawn second? Let's use the counting principle to help us out here. We've got 1, 2, 3, 4, 5, 6 slips of paper. So there's 1, 2, 3, 4, 5, 6. If my event is that A is drawn first, how many choices do I have for this first letter? Just one. And B is drawn second, how many choices do I have for this letter? Just one. Then how many choices do I have for the next slip of paper? It could be any number I want except for A and B. So that would be 4, 3, 2, and 1. That's going to be 24 different ways that I could have A be drawn first and B be drawn second. This is the number of elements in my event. Now I've got to figure out the number of elements in my sample space. If this is my event, the number of elements in my event is 24. How do I find the number of elements in my sample space? How many choices would I have for the first letter if I'm looking at all possible arrangements? And then 5, and then 4, and then 3, and then 2, and then 1. The number of elements in my sample space is equal to 6 times 5 times 4 times 3 times 2 times 1. And that happens to be 6 factorial. 6 factorial, to get to the factorial, first you put the 6 on the home screen, then you hit math, go over to probability, factorial is number 4, hit enter, and we see that 6 factorial is 720. Putting all this together, the probability of my event will be equal to the number of elements in my event divided by the number of elements in my sample space, and when I put that into the calculator, what do I get? 0.033. Number 50. A lot of 1,000 components contains 150 that are defective. 2 components are drawn at random and tested. Let A be the event that the first component drawn is defective, and B be the event that the second component drawn is defective. Find the probability of A. So if I'm drawing 2 components, what's the probability that the first one's defective? This is just going to be equal to the number of defective items divided by the number of elements in my sample space. There's 150 defective items out of 1,000 items, and that's going to be 0.15. The next few questions are basically just making sure you know how to use your calculator, and we'll do these on our calculator together. To do 10 factorial, we first put 10 on the home screen, then we hit math, go over to probability, down to number 4, and hit enter. There's 10 factorial. To do the permutation, we have to put the 10 on our home screen first, then we hit math, go over to probability, permutation is number 2, and we want to select 4, hit enter. To do the combination for number 53, we would do 7, hit math, go over to probability, number 3 is combination, and we're choosing 3, we hit enter, and these are our answers for these 3 problems. So the answer to 51 is 3,628,800. The answer for number 52 is 5,040. And the answer for number 53, this is 51, 52, 53. The answer to number 53 is 35. Number 54. At a campus cafeteria, a diner can purchase a meal deal that consists of an entree, a side dish, and a dessert. There are 3 choices for the entree, 5 choices for the side dish, and 3 choices for the dessert. How many different meal deals are possible? Use your multiplication principle of counting. So I just draw a blank for all the things that I have. I could have an entree, a side, and a dessert. And then you fill in your choices. How many choices do you have for the entree, and for the side, and for the dessert? There's a total of 45 different meal combinations possible. Number 55. On a TV game show, a contestant is shown 10 products from a grocery store and is asked to choose the 3 least expensive items in a set and then correctly arrange these 3 items in order of price. And how many ways can the contestant choose the 3 items? We have 10 to choose from. Does order matter here? Yeah, order matters because you're asked to arrange them in order of price. If order matters, use permutation, and this needs to be on your formula sheet. with permutations, order matters. So we put the number of items we have available to choose from first, and then we use permutation, and we're selecting 3 out of those 10 items. On our calculator, we would do 10p3. Ooh, since I have this as the last thing, I'm just going to hit second enter. It brings back the last thing I typed in. Move my cursor over and change the 4 to a 3, and I've got it. That would be 720. Number 56. The numbers 1 through 10 are written on separate slips of paper, and the slips are placed into a box. Then 4 of the slips are drawn at random. What is the probability that the drawn slips are 1, 2, 3, and 4 in that order? This is our event right here. The number of elements in our event is going to be equal to 1 because there is only one way to draw the slips of paper in order 1, 2, 3, 4. And that is to draw a 1 first, then a 2, then a 3, then a 4. The number of elements in our sample space is the number of different arrangements of the order of numbers that we could come up with when I'm drawing 3 out of the 10 that I have to choose from. Because order matters, I use permutation. I have 10 slips of paper, I'm only drawing 3. We did 10p4 up here, and that was 5040. That was on number 52. Putting this together, then the probability of my event is equal to the number of elements in my event divided by the number of elements in my sample space, and this is going to be equal to, if you put it in your calculator, 0.000198. Let's do this one on our calculator. If you have 1 divided by 5040, your calculator is going to give you your answer using scientific notation. This right here means that you're looking at 1.98 times 10 to the negative 4. If you will move this decimal 4 places to the left because of the negative exponent, you end up with this number right here. There's 3 zeros and then the 198. So to get my answer that's not in scientific notation, I would take this decimal and I would go 1, 2, 3, 4, put the decimal there, and then fill in the gaps here with zeros. So that's 0.000198. And by doing this, changing the scientific notation to the standard notation, I get my answer that I want right here. Remember, probabilities have to be a number between 0 and 1. When you just look at this, that's not a number between 0 and 1. If you see a number that's bigger and you put in a probability, look for that negative exponent there. That E stands for exponent. Number 57. A committee consists of 10 women and 7 men. 3 members are chosen as officers. What is the probability that all 3 officers are women? First of all, does order matter? Think about what you're doing. You're selecting an office. You could either be president, vice president, or secretary, depending on what order you're chosen. Order does matter here. Because order matters, what do we use? Permutation. Order matters because I'm looking at officers. If it was just to like serve on a committee where you're either on the committee or you're not on the committee, order wouldn't matter. But here order does matter. So my event is that all 3 women are selected. The number of elements in my event would be, I take the 10 women and I'm picking 3 of them, and 10p3 we already saw earlier was 720. My sample space is everybody. There's a total of 17 people on the committee. So my sample space would be every possible combination or arrangement of people out of the 17. So it'd be 17 pick 3. So we go to our calculators. So now I'm going to do 17 math, probability, number 2, I'm picking 3, hit enter, and I get 4,080. Putting this together, then the probability of my event is going to be equal to the number of elements in my event, which is 720, divided by the number of elements in my sample space, which is 4,080. And when I put that in my calculator, what do I get? We'll call it 0.1765. 58. Determine whether the random variable described is discrete or continuous. The number of minutes you must wait in line at the grocery store. That's continuous. Typically, I said no, if you see number of, it would be discrete, but this is one time that it is continuous. Time is always measured on a continuum. The total value of a set of coins. Discrete. Money is discrete. The number of three-point shots made in a basketball game. You can't have a fraction of a shot. It's discrete. The length in seconds of a randomly selected TV commercial. That would be continuous. It's time. Number 62. Determine whether the table represents a discrete probability distribution. In order for it to be a discrete probability distribution, there's two conditions that have to be satisfied. First of all, your probabilities have to be between 0 and 1. Second of all, the sum of all of the probabilities has got to be equal to 1. Knowing that those two conditions must be satisfied, does this represent a discrete probability distribution? Yes, it does. Add up these numbers. They add up to 1. All I need to do is just add these numbers up, and these numbers add up to 1. That's what this means right here. That capital sigma means add those numbers up and you get 1. On 63, I can tell right away 63 is a no because I have a negative probability. So 63 is not a discrete probability distribution. What about 64? All of the individual probability values are good, but do they add up to 1? Nope, it's more than 1. The sum of p of x is greater than 1. Number 65. The instructions say to compute the mean of the random variable with the given discrete probability distribution. The formula for the mean is equal to the sum of x times p of x. Since there's only 4 of these, I could probably do this by hand and be okay, or I could use my calculator. Which do y'all prefer to do? Fine, I'm going to do them by hand. X times p of x. I just look at the product. 0 times 0.2 is 0. 10 times 0.2 is 2. 25 times 0.4 is 10. 30 times 0.2 is 6. And when I add these up, I get 18. Now to get the standard deviation, I'm not going to do this by hand. I am going to go to my calculator and put these data into the list. So I hit stat, enter, and type in my data. You put your x's in list 1, your p of x's in list 2, and then you're going to go back to your home screen. Once you do that, we're going to hit stat, go over to calc. We want the one variable statistics, but we want our x's to be list 1, but this is where we use the frequency list is list 2. That hits second 2 to put a list 2 right there in your calculator, and then hit calculate, and we get the standard deviation is 7.648. We'll call that 7.6. We're going to put x in list 1, p of x in list 2, go to the home screen, and then we're going to hit stat, go over to calc, and hit enter. And this is where your list is list 1, your x's, but your frequency list is list 2. So this is what your input screen looks like. Alright, number 67 says fill in the missing value so that the following table represents a probability distribution. These are the probabilities right here. In order for it to be a valid probability distribution, all of these numbers have to add up to what? 1. They don't currently add up to 1, so if we go to our calculator and we type in the numbers that we have 0.05 plus 0.47 plus 0.32. That gives us 0.84. If we need this to add up to 1 and it doesn't, it adds up to 0.84. To figure out what is missing, we do 1 minus 0.84, and we see that this has to be 0.16 because all of these numbers, these probabilities together have to add up to 1. Number 68. The following table presents a probability distribution for the number of vacations X taken last year for a randomly chosen family. Find the probability of 1 or more. 1 or more is all of these. Or I could just take this 1 and use the complement and say it's 1. I could either add all these numbers up, or I could do 1 minus 0.15, because I know all of these have to add up to 1. I prefer to use less arithmetic and say that this is going to be 1 minus 0.15 to give me 0.85. It's everything but that. I'm using the complement. If you get your calculator and you add these four numbers up, you're going to get the same thing. You're going to get 0.85. I just didn't want to do this in my head. It's easier for me to subtract 0.15 from 1. Number 69. The following table presents the probability distribution of the number of vacations X taken last year. Find the probability that a family took at least 3 vacations. At least 3 vacations means that I took 3 or 4, and that's it. It's these two numbers. So this would be equal to 0.05 plus 0.04, and that gives me 0.09. Number 70. For this, the following table presents the probability distribution of the number of vacations. Compute the mean. How do I find the mean again? I add up x times p of x, don't I? There's 5 numbers here. I don't want to do it by hand. I want to do it on my calculator. So let's go to Stat, Enter. I've got to clear out the data in my list, and then I put my x's in list 1, and then I put the p of x's in list 2, and go to my home screen. Then I want to hit Stat, Calc, Enter to go to my one variable statistics. It's already set up for me. My list is list 1. My frequency list is list 2. I go down to Calculate, and x bar is the mean. I get 1.18. This uses the same steps as number 66, but my answer is x bar because I'm looking for the mean here, and before I was looking for the standard deviation. Number 71. The following table presents the probability distribution for the number of vacations X taken last year for a randomly chosen family. Compute the standard deviation. Too bad these numbers didn't stay the same. I could have used the same output. But to find the standard deviation, it's go through the same process, but I'm now going to have to change the data in list 2 because the probabilities are different for this problem. So I'm just going to type over what I have and go back to the home screen, hit Stat, Calc, Enter, go down to Calculate because list 1 and list 2 are where they belong, and I get my answer. And now the standard deviation is this number right here. So my answer here would be 0.86. Number 72. A survey asked 863 people how many times per week they dine out at a restaurant. The results are presented in the following table. Consider the 863 people to be a population. Let x be the number of times per week a person dines out for a person sampled at random from this population. Find the probability that a person dines out 4 or more times per week. I've got my x's here just fine, but I don't have p of x. I have a count of frequency. I need to find p of x. Well, p of x is going to be each of these frequencies divided by 863. So with this little modification, I now have probabilities. We wanted to find the probability that a person dines out 4 or more times per week. 4 or more means that I need to add these up. This is my event. So the number of elements in my event is equal to, I could just add these numbers up. So that's 60, 87, 88, that's 108, 9, 10, 11, 112 divided by 863. Oops, actually 112. The number of elements in my sample space is 863. So the probability of my event is equal to 112 divided by 863. And what do we get for that when we put that in our calculator? 0.13. Because of the way this question was asked or worded, I didn't have to divide each of these to get individual probabilities. I could do that at the end once I got my count. So I take the number of elements in the event divided by the number of elements in the sample space, and that gives me the probability of the event. 73. An investor is considering a $15,000 investment in a startup company. She estimates that she has a probability of 0.15 of a $5,000 loss, 0.15 of a $10,000 loss, 0.15 of a $30,000 profit, and 0.55 of breaking even, a profit of 0. What is the expected value of the profit? Do you remember us doing these? We have to set up a table for these where x, our random variable x, is going to be the profit and then the probability of x. So a probability of 0.15 of a $5,000 loss. Because it's a loss, x has to be negative. A probability of 0.15 of a $10,000 loss. And a probability of 0.15 of a $30,000 profit. That one's positive because it's a profit. And a probability of 0.55 of breaking even where you have 0 profit. The expected value is another name for the mean. And the mean is just the sum of x times p of x. I think this one's easy enough we can do it without going to the calculator, if you'll help me out just a little bit. 5 times, or negative 5,000 times 0.15 is what? Negative 750. And then negative 10,000 times 0.15 is going to be negative 1,000. And 30,000 times 0.15 is 4,500. And 0 times anything is 0. Oh, there it is. Negative 1,500. I have an error right here. This isn't negative 1,000, it's negative 1,500. This is why we use calculators. X times p of x for each of these. Negative 5,000 times 0.15 is negative 750. Negative 10,000 times 0.15 is negative 1,500. Through 30,000 times 0.15 is 4,500. When we add all this together, we get $2,250. So we expect a profit of $2,250. Number 74. Determine the indicated probability for a binomial experiment with the given number of trials and the given success probability p. So NP, and we're looking for this when x is 12. We use what on our calculator to do these? Binomial PDF. How do I get to it? Second, vars. And if you have the newer operating system, I think it's letter A. If you have the older one, it may be 0. So N is 15, P is 0.4, and X is 12. We go to our calculator. Second, vars. Go up to letter A, the binomial PDF. The number of trials is 15. The probability of success is 0.4. X is 12. And we get 0.0016. On 75, we're looking at fewer than 4. The probability of fewer than 4. This is where we use the binomial binomial CDF. We use the PDF for a particular value. We use the binomial CDF for a cumulative value, and it accumulates from 0 to x. Fewer than 4 would be 0 is fewer than 4. 1, 2, 3. Do I include 4? Huh? No, because 4 is not fewer than 4. So for this one, I would use the binomial CDF, where n is equal to 12, p is equal to 0.6, and x is equal to 3. But it's got to be the CDF. So we do second, vars, go up to letter B. N is equal to 12. That was given. That's the number of trials. P is our probability of success. That was 0.6. And X is what we're going up to. And we're going up to 3. So this is 0.153. On number 76, we're asked to find the probability of 8 or more out of 10 trials. What would be the complement of the event? The complement of 8 or more is 7 or less, isn't it? So that would be everything from 0 to 7. Well, guess what? That's my binomial CDF. So I can use the complement. The probability of my event is going to be 1 minus the probability of the complement of my event. The complement of my event, to get that probability, I would do the binomial CDF, where n is 10, p is 0.4, and x is 7. So that would be 1 minus second bars, go up to letter B. I have 10 trials. The probability of success is 0.4. And now I want my x value to be 7. And I get 0.0123. Number 77. Determine the indicated probability for a binomial experiment with a given number of trials and successes. 3 or fewer. Would I use the PDF or the CDF here? I would use the CDF. What would x be on it? If you have only one, like x equals a number, a particular number, you use the PDF. But if you want to go from 0 up to a number, use the CDF. 3 or fewer means 0, 1, 2, or 3. So this would be the binomial CDF, where n is 11, p is 0.1, and x is 3. And when we put that in our calculator, we get what? 0.9815. Number 78. A student takes a true-false test that has 12 questions and guesses randomly at each answer. Let x be the number of questions answered correctly. Find p of 5. First of all, this is a binomial because we have a fixed number of trials. What is my fixed number of trials? The 12 questions. My questions are all independent of each other. The probability of success stays the same for each question because they're all true-false questions. As a matter of fact, what is my probability of success? 0.5. So this would be the binomial PDF because now I have a particular value. So I would do the binomial PDF with 12.5 and 5 for x. And when I put that in my calculator, what do I get? Do you see why I use the PDF on 78 but I use the CDF on 77? I had a particular value for x here. With 3 or fewer, I went from 0 up to 3. So I accumulated CDF. Particular value PDF. Let the alliteration help guide you. Make sure you put that on your formula sheet. Number 79. The Australian sheepdog is a breed renowned for its intelligence and work ethic. It is estimated that 40% of the Australian sheepdogs weigh 65 pounds or more. A sample of 13 adult dogs is studied. What is the probability that exactly 9 weigh 65 pounds or more? This is a binomial distribution because I have a fixed number of trials, the 13 dogs. The probability of success is 0.4. because we were told that there's 40% are over 65 pounds. And then x for this problem is 9, a particular value. So I use the binomial PDF, where n is 13, p is 0.4, and x is 9. And when I put that in my calculator, what do I get? 0.0243. Number 80. Once again, the Australian sheepdog. Now they're saying that 45% of them weigh 65 pounds or more. We still have a sample of 13 dogs. What is the probability that no more than 3 of them weigh 65 pounds or more? No more than 3 means that it could it be 0? Is 0 no more than 3? Is 1 no more than 3? Is 2 no more than 3? Is 3 no more than 3? Is 4 no more than 3? No. So now I use the binomial CDF. So n is equal to 13. P is equal to 0.45. And I'm going to let x be 3 with the binomial CDF. Make sure you change that p to 0.45 from the last problem. And when we put that in our calculator, what do we get? 0.0929. Number 81. The Australian sheepdog, once again, it's estimated 30% of the Australian sheepdogs weigh 65 pounds or more. A sample of 14 adult dogs is studied. What is the mean number of dogs who weigh 65 pounds or more? This is a binomial distribution. The mean for a binomial distribution is equal to n times p. For this particular problem, what is n equal to? 14 times what is p? P is the percentage of dogs, 30. And 14 times 0.3 is 4.2. So out of 14 dogs, on average, we would expect 4.2 of them to be 65 pounds or more. Of 82, 45% weigh 65 pounds or more. 14 adult dogs. What's the standard deviation? The formula for standard deviation for binomial distributions is sigma equals the square root of npq, where q is 1 minus p. So for this problem, we get the standard deviation is going to be the square root of 14, because n was 14. Here p is 0.45. So q is going to be 1 minus 0.45, or 0.55. So we get our standard deviation is equal to what? We'd do this on the calculator. Square root of 14 times 0.45 times 0.55. And we get 1.8615. All right, number 83. It's estimated that 25% of households own a riding lawnmower. A sample of 17 households is studied. What is the probability that exactly 9 of these own a riding lawnmower? Binomial PDF. What do I plug in place of n? 17. And what do I use for p? 0.25. And what do I use for x? And when I put this in my calculator, I get, beautiful, 0.0093. Number 84. It's estimated that 30% of households own a riding lawnmower. A sample of 17 households is studied. What is the mean number of households? The formula, once again, for the mean is n times p. So here the mean is going to be 17 times 0.3, 5.1. And number 85 says that 45% of the households own a riding lawnmower. A sample of 10 households is studied. What is the standard deviation? Once again, the formula for the standard deviation is the square root of npq, where q is 1 minus p. So the standard deviation will be the square root of 10 times 0.45 times 0.55. And when we put that in our calculator, we get, beautiful,